Welcome to Mastering Solutions. So this is a three-part MCAT style problem. And in this one, what's helpful for these is, of course, to go through and let's try to eliminate anything that doesn't make sense. So if we look at B, they're talking about the index of refraction, but what we're talking about in the question is reflection. So we're not refracting anything, so the index of refraction doesn't matter, so B can't be right. With the Doppler effect, we are not having a significant enough speed on the wings, so the difference compared to the speed of light is way smaller, so the Doppler effect wouldn't really be in effect here, and so C doesn't make sense either. So if we look at A and D, these are the only two that kind of make sense. And so for A, if we look at it, a diffraction pattern appears only at certain angles. Now that's tempting, but we're dealing with sunlight. And so with sunlight, it has all of the different wavelengths in it. And so if it was only one wavelength, then maybe we'd be tempted to go with that answer. But in this case, D is our correct answer, because as the angle changes, we're just getting a different color from the differences in the constructive interference for different colors. So for this second question in our three-part MCAT style problem, let's go through again and try to eliminate anything that doesn't make sense. So for this, we can see that the top two are talking about changes in frequency and the bottom two are talking about changes in wavelength. If we remember our equation, lambda for a certain material is equal to the wavelength of that material in a vacuum or in air divided by the index of refraction. When we remember the properties of light, the frequency of light doesn't change material to material, so we can immediately cross off A and B. So now we have to figure out, is the wavelength of light less than in air, or is the wavelength of light greater than in air? If you remember, the index of refraction for air, of course, is 1. The index of refraction for acetone is, of course, going to be larger than the index of refraction for air. If we come back to our equation here, as this increases, then that means the whole value is going to decrease. So the wavelength in a certain material will therefore go down. So our answer in this case then is going to be the wavelength of light is less than in air because the index of refraction went up. All right, and now we're on our last part, part 3 of this MCAT style problem. Let's go through and see if there's anything that we can eliminate from these. Now, one of the ones that I want to point out is that the scale's density is different from that of air. But does the density matter to index of refraction? The answer is no, it doesn't. There are some materials, like for instance, glass has a index of refraction of 1.50, and glass is fairly heavy. Now there's another material that often gets used for glasses, and it's called Trivex. Now, Trivex is actually pretty light, significantly lighter than glass for when they make people's glasses. The index of refraction for Trivex is 1.53. So not only are they similar, but it's actually a higher index of refraction. So if it was just density, this should be heavier, but Trivex is really light. And so the density does not matter for index of refraction. And now if we look at part D, yes, different colors of light have different wavelengths, but that's not why the light is reflecting from the scale, so we can eliminate D. Why does light get reflected in the first place? We've talked about that in a lot of the questions. It gets reflected, and of course there's some transmission because of differences in index of refraction. So the answer to this question will of course be A. And so if we look at B, the index of refraction is similar to that of glass. Well, it doesn't really matter that it's similar to glass. We also get reflections off of diamonds, which has a way different index of refraction from glass. And so this doesn't matter, and the answer is A. Because the index of refraction is different from air, because light reflects off of transparent surfaces because of a change in index of refraction. So we're going from air to the butterfly's wings, and so that's why the light reflects from it.